Hello, my name is Kanak Yadav. Today we are going to study about the topic audio components, digital audio and digital audio processing. So here's the overview of the presentation. First, we will discuss about the goals and objectives, then a small introduction to sound, then two different types of audio, its components, the formats and interfaces, and its processing in the end. So first and foremost, the goal and objectives. As our topic is audio, digital audio, so we are here to gain a comprehensive knowledge and understanding about the audio. However, it is captured, processed, transmitted, and reproduced. That is, every action that can be done on an audio is what we are going to understand in this presentation. Here are the objectives to understand the properties of sound, identify the key components, the hardware components of audio, gain knowledge about its formats and interfaces, and recognize the real world applications. As we all know, sound plays a critical role in how we interact with the world. We hear, that is sound. We speak someone, we communicate to someone through speaking, through sound. So that is sound, and audio plays a very key role in entertainment, education, communication, and etc. in our daily lives. If we talk about what is sound, it is basically a vibration that travels through a medium which is air or any mechanical wave. Its key properties are the frequency, amplitude, and waveform. Amplitude refers to the loudness of the sound. Naturally, sound is analog and continuous in form. As we are seeing that technology is moving and technology is growing day by day, sound can be captured, manipulated, and shared in many powerful ways. So, we talk about digital audio. What is digital audio? It represents sounds as discrete numbers instead of continuous waveforms. As we saw earlier, that sound is naturally in analog and continuous form. So digital audio represents the same sound as discrete numbers instead of the continuous waveforms. And it is basically done through sampling and quantization of the analog audio. Sampling is capturing of sound at specific intervals, that is according to the frequencies. Here is the given diagram of the discrete levels that are shown in a digital audio that are taken in a digital audio. The benefits of digital audio include easy storage and duplication. When you have to duplicate and store some piece of audio, it is easier to store it in a digital form rather than analog form. It has high degradation, it has low degradation and high fidelity. It is very simplified editing and processing because digital audio has discrete values, and hence when you have discrete values rather than continuous values, it's easier to process and edit those values. We see the applications of sound and digital audio in our day-to-day lives, be it entertainment field, communication field, gaming field nowadays, with real-time sound effects and immersive game environments. Others are broadcasting, that is the radio and live streaming. We all know about that. Assistive technology like speech synthesis, speak recognition systems that are available nowadays. Education, online courses, and many learning apps use audio content. Now, if we see the difference between analog and digital audio, so analog, as we understood earlier, is a continuous signal that varies over time, which is the natural form of the sound, and digital audio is the discrete values representing sound through sampling and quantization. It is easier to store, edit, duplicate, and manipulate, as we saw earlier. So here is the diagram. As we can see, the original sound wave and the analog sound wave are similar because the original form of a sound wave is of an analog sound wave. And the next we see is a digital sound wave which has discrete values. It is the same wave that is converted to a digital sound wave through sampling and quantization process. Next, we move on to the key audio components. So first is microphones, then amplifiers, speakers, and converters. These are the key. There are many more out there, but the main are these. Microphones, they convert sound into electrical signals. Microphones, as in short, we understand by mics. Amplifiers, they boost the audio signals. Speakers convert electrical signals back into the sound. So we have noticed the microphones and speaker in our day-to-day lives. Whenever a mic is connected to a speaker, the microphone converts sound into electrical signals. It goes into the speaker, and those electrical signals are converted back into the sound that we hear from the speakers. Next are converters. There are two types of converters, ADC and DAC, analog to digital and digital to analog. Microphones are of three types: dynamic, condenser, and ribbon. The dynamic ones are more durable and good for when you have a live sound, when there is a need of a live sound. Condenser microphones are more sensitive and they are ideal for the studio recordings such as the music recordings, the podcast recordings, etc. The ribbon ones are smooth sound and they are very delicate build. Again, when you have choices, so then you have to depend on the use case, whatever be the use case, and then you use whichever suits the best. Next is analog to digital conversion, ADC. It uses three processes. First is the sampling, then is the quantization on the basis of the Nyquist theorem. Here are the simple examples, simple diagrams to understand the ADC. Then there are digital audio file formats. Now if you any file has a file format which represents the content it has in it. For example, a PDF file has the extension PDF. PDF is a file format. JPG is a file format for pictures, PNG is a file format for pictures. Similarly, file formats for digital audio are of two types, lossless and lossy formats, which is the WAV and FLAC, and the lossy ones are MP3 and AAC. It again depends on need for quality versus storage. When you need the quality, you use the lossless ones, and when you need the storage ones, you use the lossy formats. So here, the digital audio interfaces, we have USBs, HDMIs, the optical Toslink, and the Bluetooth. The USB, HDMI, and optical are the connection oriented interfaces. The Bluetooth is connectionless, or we should say that it is more of a wireless connection because all these three are some sort of a wired connection. USBs are common for microphones. We all are aware about USBs. HDMI is the audio plus video in home theaters and in our televisions, etc. And the optical are the high quality is used in the high quality digital audio. Bluetooth is wireless convenience, as we mentioned. There might be some compression of the data, the audio, the video. Bluetooth we use on our usual basis, on our daily basis. We connect our phones to Bluetooth speakers, to Bluetooth earphones, and we use those devices. Now, the last topic is the digital audio processing. So, mainly processing involves the manipulation and enhancement of audio signals using the digital techniques. To manipulate something, you need some algorithms and some software tools. So there are the manipulations that can be done, and the applications of the digital audio processing include removing noise from recordings. So there are many recordings that contain unnecessary noises, like some background noises. When you want to remove them, uh, the digital audio processing can be used. Some algorithms of these can be used. When you want to enhance some instruments or vocals in some studio recordings, it can be used, and many more. So these techniques are filtering, equalization, compression, limiting, reverb, delay, and etc. So which basically does nothing but enhance or modify whatever the existing audio quality be. These processes or these techniques modify and enhance your audio. When we talk about filtering, it removes the unwanted frequencies. The name suggests filtering, which is removing the unwanted things, and here in this case it is removing unwanted frequencies, because sound is a sound has a property of frequency, which is the very important property. Equalization, it adjusts specific frequency bands for clarity and tone shaping. Compression is it controls the dynamic range, so that the volume levels be balanced. Limiting is prevents audio from exceeding a maximum level. And reverb is nowadays very common and very popular among the young people, because it simulates the natural reflections of a sound in a place. So when you hear a reverbed audio, it sounds like it's some echo in the space around you. Then there's delay. It repeats a signal after a set time interval to create echo effects. Noise reduction, time stretching, and pitch shifting are some other techniques as well. So audio synthesis is also a part of this. Audio synthesis is basically generating sound through software, hardware in audio synthesis. Its types are three: subtractive, FM, and wavetable. These is basically used in the music, the games, and the virtual instruments. There are many apps of virtual instruments where there is not actually an instrument, but you can download that app on your phones, on your devices, and you can, whenever you, for example, if you have a virtual instrument of a piano and you touch the white and the black keys, it generates sound. So that is used in audio synthesis because it's generating sound through a software, not an actual hardware. The next we have is the audio editing softwares. Whenever your audio is to be processed, you need some editing software. Some popular softwares are Audacity, Pro Tools, FL Studio, and the common features that all of these softwares has are adding effects, adding automation, adding multi-track editing. So with this, we come to the end of our topic. We studied audio components, digital audio, and digital audio processing form the foundation of modern sound technology, and how is it done. We covered every topic related to audios, digital audios, and its processing, the components as well. These are some resources for further study. Here are the references of the presentation, and here is the acknowledgement. Thank you.